Hey there, it's Joey. Welcome to Joey's Tech. In this video of Joey's Tech, we are going to look into the filling bookcase shelves problem. I have taken this problem from LeetCode. It is very interesting, and let me tell you that once you learn this problem from its very core, it is going to give a great boost to your problem solving skills. The problem statement is a bit tricky, but I have done my best to explain it to you in the easiest manner possible. Let's take a look at it. Alright, so you got some books which you need to store in a bookshelf. Now the books are given to you in some sort of sequence. That means a predefined order has been given to you in which only you have to place the books in the bookshelf. Now each bookcase shelf has a width denoted by a variable shelf underscore width. Each book which is given to you has got two attributes. Number one is thickness and number two is height. You need to choose books to place on a bookcase shelf or a rack such that their combined thickness is less than or equal to the variable shelf underscore width. So let's say if you've got 3 books and the shelf underscore width is 3, the thickness of book number 1 is 1, the thickness of book number 2 is 2, and the thickness of book number 3 is also 2. Only you can place the first 2 books in the bookshelf because the combined thickness of the first 2 books is going to be equivalent to 3. You can't store the third book because that is going to exceed the width. So once you have placed certain amount of books in a particular rack, then obviously you will have some more books remaining, for which you'll have to build another level of bookcase shelf or a rack. Now, the height of the rack which you are going to build will be the maximum height of the books which you are going to place in that rack. So let's say you have got 4 books. The height of book number 1 is 1, of book number 2 is 2, of book number 3 is 1, and of book number 4 is 3. The maximum height from this set of books is 3. So the height of the rack which you are going to create has to be 3. Your final ask is to build the bookshelf with the minimum height possible by fitting all the books in different racks of this bookshelf. This is the final ask. So here are the books given to you. Like I said, that there are 2 attributes of a particular book. Number 1 is thickness, number 2 is height. So here from 1, 1, you can say that the first one represents the thickness, the second one represents the height. For book number 3, the attributes are 2, 3. So 2 represents the thickness and 3 represents the height. The shelf width is 4. That means books with a combined thickness of equal to or less than 4 only can be placed on a particular rack. So this is the arrangement which is going to give you the minimum height of the bookshelf. If I place book number 1 on rack number 1, it is going to give me the height as 1. Then I am going to place book number 2 and book number 3 on second rack. So the maximum height is going to come out as 3 obviously. So 3 plus 1 till here is going to give me 4. That means for the first 2 racks I am getting the combined height as 4. Now the last 4 books, as you can see, I can place on a single shelf. If I place them on a single shelf, then the maximum height of that particular shelf is going to come out as 2. 2 added to my previous height, which is 4, is going to give me 6. So 6 is the minimum height of this bookshelf. One important thing which you have to remember is that the combined thickness of all the books placed on a single rack must not exceed 4, which is my shelf width. So as you can see, the last 4 books have been placed on the last shelf, and the combined thickness of those 4 books is coming out as 4, which is equal to our shelf width. Hence, this arrangement is possible. We are going to solve this problem using dynamic programming in our framework, and I hope that you have got an idea of this problem. If the problem statement is not clear to you still, then I recommend you to revisit the explanation. It will be clear to you. Also, If you haven't subscribed to my channel already, then do hit the subscribe button and hit the bell icon because that impacts my ability to create videos like such in a direct manner. Now let's start solving the problem in our framework. Before we start solving the problem, let's get familiar with the setup here. So this is the book array. The first row here represents the width of all the books. And the second row represents the height of each of the books. The shelf width is given as 4. There are two variables, width and height, running width and running height, that we are going to use for our own advantage. Now this is the setup. This is the graphical representation, the optimized graphical representation of the bookshelf I have placed here, which we can refer to in order to understand the solution better. This is our solution array. These are the indexes of the cells. We'll start filling the cells from here, and the final cell, which is this one, is going to give us our answer. Now, the base case, the base solution, the base value, the value of the base cell is going to be 0, which we have placed, which we have assigned to facilitate our algorithm. We are going to start from here. This book, the cell for which we are calculating the height of, will be represented by I. So let's consider book number 1. Now when there is only book number 1 given to us, then we have to place it in rack number 1. We just have to confirm if its width is less than the shelf width, which it is, because we have 1 and 1 is less than 4. So we can place book number 1 in a rack, and the height of the rack will be height of book number 1. So what the algorithm, how the algorithm is going to work, it is going to add this one to this 0, okay, because it has to consider the previous state, which you are going to learn in a moment. But the algorithm is going to add 1 to this 0. It is going to get 1. It will assign 1 to this cell. So consider this first cell also as one of the base cases. Now I moves one cell to the right. Now there are two scenarios we have to consider from here. One is that we already have the previous arrangement, the height of the previous arrangement calculated. So the first case is that we place the current book that we need to place in a different shelf, in the next shelf. And the second case is that we try to place this book, we try to adjust this book with the previous books and check which arrangement gives us the minimum height. So for arrangement number 1, what we are going to do, we are going to simply place this book in the next shelf. We are simply going to build the next shelf for it. So the width of this book is going to be 2 and the height of this book is going to be 3. Now if we place this book in the next shelf, okay, the first case, then this 3 or this 3 will be added to the height of the previous arrangement. So we are going to get 4, which we'll place over here. Now we are going to work on our second case, that is to try to place this book with some of the previous books in a single shelf, in a separate shelf, to check if we can get the minimum height out of it. So for that we are going to use another variable j. So first what we are going to check, we are going to try to place second book with the first book. Okay, so for that we'll have to first check whether the combined thickness or the combined width is less than 4. So till now the running width was 2. 2 added to this one is going to give me 3. Okay, so this is the combined width of both the books. 3 is less than 4. That means there is a chance of placing both the books together in a single shelf. Now we are going to check for the maximum height, because the height of the rack in which we are going to place these two books is going to be equal to the height of the taller book. So here the running height was 3. We are going to compare it with this height. Okay, we are going to compare it with the height of book number 1. So 1 and 3, which is maximum? 3, of course. Alright, so the height of this shelf is going to be 3. Now this 3 we have to add to the previous arrangement. Okay, so the two books which are under consideration of being placed together, we are assuming and we are adding this maximum height to the height of the arrangement previous to these two books. So the height was 0, and that is why we placed a 0 over here to facilitate our algorithm. 0 plus 3 is going to give us 3. Now we are going to compare this 3 with the value already placed here. That means we are comparing the heights of both the scenarios now. So scenario number 1 was that the book was placed in a separate shelf. Scenario number 2 is book number 2 is placed with book number 1. So there we are getting height as 3, and in the first scenario the height was 4. So which is minimum? Obviously 3. So I am going to put 3 over here. Looking over here, if we have only these two books, then it makes sense to place book 2 with book 1 in a single shelf. Okay, so that way we'll have to create a bookshelf of height 3 only. Okay, if we are going to put both of them in this arrangement, then the height is going to come out as 4, and we are striving to get minimum height. Alright, as we progress, you are going to understand it better. Now moving on to the third book. So J will come over here. Okay, now we consider book number 3. So first thing which I am going to do is consider case number 1. That means book 3 is solely in the next bookshelf. I am building a bookshelf for book 3. Now I am going to update the width and the height, running width and the running height. So running width is going to be 2 and running height is going to be 3. 3 added to this 3, that means the height of the previous arrangement, is going to give me 6. Okay, so this tells me that when 1 and 2 are placed next to each other in a single shelf and I put 3 in the next bookshelf, then the height is going to come out as 6. You can calculate it. Now I have to consider the second case, which is trying to put book number 3 with some of the previous books in one shelf and to check if I can obtain minimum height out of there. So my J is over here. That means I'll consider first placing book number 2 and book number 3 together. So the running width is 2. This 2 will be added to this 2. So I'm going to get the running width as 4. So you can see it is equal to the shelf width. That means I can place book number 2 and book number 3 together. The running height will be 3 again, because this 3 earlier, that means the height of book 3 compared with the height of book 2 is going to give me 3, because if we put them together in a shelf, I'll have to create a shelf of height 3 only. So I've got the running height as 3. Now this 3 will be added to the height of the previous arrangement, and that is 1. So we need to consider the height which is stored in the cell immediately before J. Okay, so 1 plus 3 is going to give me 4. Now that 4 is less than 6. That means we have got an arrangement here with minimum height. So I am going to place 4 over here. Alright, that means if I place these two books together and 1 in the previous shelf, I get the height as 4, and that discards my previous arrangement which was giving me the height as 6. And now this particular arrangement makes sense. Alright, now J moves one cell to the left. Okay. Alright, the running width was 4. Over here, what we are checking, if we can place book number 1, 2 and 3 together. So running width is 4. If I add 1 to it, I am going to get the running width as 5. If I update it over here, first thing which I will check whether it exceeds my shelf width. Yes, it exceeds my shelf width. That means there is no chance we can place book number 1, book number 2 and book number 3 together. We'll have to settle with this arrangement. Alright, Now I'm going to clear these two variables and I moves one step to the right. So book number 4 gets checked now. I'm going to place J over here. So I'm just trying to work on scenario number 1, which is placing book number 4 in the next shelf. So here the height is 1. I'm simply going to add it to this 4. I get the height as 5, the height of the previous arrangement. Cool. Now my running width is 1 and my running height is also 1. Okay, now let's try to work on scenario number 2, which is placing these two books together because our J is here. Now the running width becomes 3. 3 is less than 4. So there is a chance of putting these two books in a separate shelf, in a single shelf, alright, in a new shelf. And the maximum height is going to come out as maximum of 1 and 3. So I'm going to update it with 3. Okay, so this shelf will be created with height 3 because book number 3 has height 3. Okay, and book number 4 can easily fit in. Alright, this 3 when added to the height of the previous arrangement, previously optimized arrangement, which is stored in the cell immediately before J, is going to give me 6. Now this 6 is greater than the height stored here. So I am not going to consider this arrangement. Alright, that is discarded. Cool. Now, just for the purpose of demonstrating the algorithm, we move J one cell to the left. Running width is 3 and running height is 3. That means we are trying to place these 3 books in one shelf. Okay, so running width is 3, J is here, so J is representing book number 2. Here the width is 2. 3 plus 2 is going to give me 5. So I'm going to update 5 over here. 5 is greater than 4, the shelf width. That means there is no chance that we can place these 3 books together. Alright, that's it. So our iterations, our J iterations must be over. The algorithm will continue, but for the demonstration purpose, we'll move ahead. So I comes to book number 5. J comes over here. Okay, let's reset WNH. Cool. Now, working on the first case, 1 will be added to this 5, so I'm going to get 6 over here. Okay, now we'll work on the second case, but first we'll update W and H. Okay, now we'll think of putting these two books together. So the running width is going to be 1 plus 1, which is 2. I'm going to update it over here. Yes, 2 is less than 4, so there is a chance of putting these two books in a single shelf. Cool. The height 1 and 1 is going to give me 1. That means when we are putting these two books together, the height of the shelf will be 1. 1 added to this arrangement, the value stored in the cell just before J, because after this arrangement only we are thinking of creating one shelf in which we are thinking of putting these two books together. So 4 plus 1 is going to give me 5, and that 5 is less than 6. So this arrangement is giving me minimum height. Okay, so I'm going to update minimum height over here. Now J moves one cell to the left. So now I'm thinking of putting these 3 books together. Cool. So the running width is 2. I add 2 to this book represented by J. I update the width as 4. And this one, when compared to this height, is going to give me 3. That means if I have to put these 3 books together, I'll have to construct a shelf of height 3. This 3, when added to this 3, is going to give me 6. Now 6 is greater than 5. Hence, we are not going to consider this arrangement. That means we are not going to consider putting book number 3, book number 4, book number 5 together. Okay. Now J moves one cell to the left. Okay. So we are thinking of putting these 4 books together. So 4 plus 2 is going to give me 6, that exceeds my shelf width, hence we'll not consider this iteration now. So now I am going to reset the values of these variables. I moves one cell to the right and j comes here. Okay, now I'm going to populate w as 1 and height as 1. That is the width and height of book number 6. So working on the first scenario, in which we are putting book number 6 in a new shelf with regard to the previous arrangement, the height is going to be 1 plus 5. So it's going to come out as 6. Okay, now we try to put these two books together. So what will be my running width? It's going to be 1 plus 1, 2. That is less than 4. So it can be considered. The height is going to be the maximum of this running height, and this height, it's 1. Good. Now I'm going to add this 5 to this one. So I'm going to get 6. Now I have 6 already here. So this 6 is not going to make any difference. Alright, so no update is going to happen. But what we are going to consider, we just now considered putting these two books together. Now we'll try to consider putting these 3 books together. So now my running width is going to be 3, height will stay as 1, and j is going to move one cell to the left, because now j is going to represent this book. So over here, what we are going to do, our height is still 1, and this one will be added to this 4, the height of the previous arrangement, previously optimized arrangement. So 4 plus 1 is going to give me 5. So we are getting an optimized value here, that 5 is less than 6. So this 6 will be replaced by 5, and this gives me a scenario where book number 6 can be put with book number 5 and book number 4 in a separate shelf, and that is what is happening over here. If you eliminate book number 7, then we are going to get the height of the bookshelf as 5. This solution is going just fine. Now I moves to the last cell, and let's update the width and height variable with the width and height of the last cell of the last book 1 and 2. J comes to its base position. Over here, simply what we are going to do, we are going to put the last book in the next shelf. So that is going to give me the value as 2 plus 5. So I'm going to get 7 over here. Cool. This is scenario number 1. Now we'll try to place book number 7 with book number 6. So my running width is going to be 2, which is going to be less than 4. Yes, they can be put together. My height is going to stay as 2, because 2 compared with the height of book number 6 is going to give me 2. I will have to construct a shelf of height 2 only. What is going to happen? This 2 will be added to this value, and I am still getting 7. I already have 7 here, so no updates take place. Okay, J moves one cell to the left. That means we are trying to place these 3 books together in one shelf. So my width becomes 3 and my height stays as 2, because 2 compared with this one is going to give me 2. Okay, 2 added to this 5, that means the height of the previous arrangement, okay, is going to give me 7. Now it is no better than this 7, so nothing happens. Alright, J moves one cell to the left. Over here, my width gets updated as 4, 3 plus this one, because we are trying to put these 4 books in one shelf. So 3 plus 1 is going to give me 4. My height is going to stay as 2. The height of the bookshelf is going to stay as 2, because 2 compared with this one is going to give me 2 again. Now this 2 added with the height of the previous arrangement, okay, that means this arrangement is going to give me 6, which is lesser than this 7. So I'm going to update this 7 with 6. Okay, so I've got a lesser height over here. That means when I'm going to put these 4 books in one shelf, then the height of the entire bookshelf becomes 6 instead of 7. And that is an optimized arrangement. Now J moves one cell to the left. So my running width is going to be 4 plus 2, which is 6, and it exceeds 4. It is greater than the shelf width. Hence this arrangement is not possible. So we are going to stop right here. The algorithm is going to go towards the left, but only the arrangement of these 4 books will be considered, like I have demonstrated here. So now we have got our final answer, and it is 6. And this totally matches with the height of the arrangement that we have got here. Now we are going to take a look at its algorithm. So this is the algorithm. Basically, this is the running program which you can put in a function and it is going to work for you. You can try it out totally. This exactly goes with what I have explained in the video. With this, we have come to the end of this video. This video was long, but it was worth watching. I hope you enjoyed watching this video. Do give it a thumbs up because that is going to encourage me a lot. I look forward to help you with algorithms and programming, and only for this video. Goodbye and take care.